Okay, before we start the lesson from Thursday, October 31st, Halloween, we want to discuss two problems from the homework on the night before, from worksheet, I think this would have been 5.9. In problem number 4, you should have got the final answer 4n/3. Lots of kids are asking if they should change that to 1 1/3 n. Well, although 4/3 does equal 1 1/3 n, we don't actually make that change when we're working with algebraic fractions usually, because we don't know anything about n. Say, for example, that n was 1/4. If n were 1/4, you can see that this fraction would become just 1/3. So since we don't know anything about the value of n, as is often the case in algebra with the variables, we don't change it to a mixed number. We'll just always leave fractions in a/b form like this. Okay, so that's to address that question that comes up often. Then this was problem 8 from the homework, and this was trying to get you to think critically about like terms. Like terms are defined as the same variables to the same powers. That being said, when you look at this problem, most kids clearly see that we have 6b squared. But then they have these other two terms, and they're not sure about them. But you should be, because the definition of like terms were the same variables, which we have in both of these terms. We have an a and a b, and a and a b. And they're all to the same power. They're all to the first power. So by the definition, these are like terms. But this last one is written out of ABC order. What property tells us we can just rearrange that? Well, the commutative property does. So this term is really the same as -7ab. Once you make those connections, you can see this simplifies to 6b squared minus 11ab. So you want to recognize those like terms even if they're kind of out of order. Think, can I put them in order, and make sure that you do. Okay, so those are those two homework problems. Now let's go with the lesson for today. So this is the lesson from October 31st. We're factoring the greatest common factor from algebraic expressions. First, let's get some vocabulary straight. I have two examples up here that we're going to use to talk about vocabulary. In the problem, 3 times 7 equals 21. The 3 and the 7 are called factors, because they are the numbers you multiply together to get 21. You know what 21 is called? Well, if you didn't, it's the product. Most kids, frankly, have that straight. But when you look at it with algebra, as in this other example, it looks a little bit different. What's going on between the 3 and the parentheses, or the 3 and the sum? Well, it's multiplication. So if it's multiplication, that means that 3 and the sum of x plus y are factors in this problem, because factors are numbers you multiply together. So it's a little strange that the sum of x plus y is a factor, but it is. All right, when we multiply 3 times the sum, what do we get? Well, we use the distributive property and we get 3x plus 3y. Well, if this is what we get from multiplying these two expressions together, then this must be called that's right, this is the product. I know it seems a little strange because it's a sum, but it is what we get as the result of multiplying these two together. So legitimately, this 3x plus 3y is called the product in this situation. What we're doing in this lesson today is we are factoring the GCF. So basically, we'll be starting here and working backwards to there. So, factoring, a formal definition that we could use, is the process of writing an algebraic expression as a product of two or more expressions. So you can see in this example on the right that we have, this is a product, and when we multiply them together we get this expression. So again, we're going to kind of work backwards. In other words, factoring in a lot of ways, with the greatest common factor, it looks like the distributive property in reverse. Okay, well, how do we do it? Well, the directions will be to factor, all right? And there's basically two steps. First, you look at the terms in the expression and find a greatest common factor if you can. When you recognize the greatest common factor in the expression, then you can write the expression as the product of that greatest common factor and the quotient that remains. Well, what does that look like in practice? Here's an example. I'm factoring 5x minus 5. I want to look at the expression, and I want to ask myself if there is a common factor in both terms. Do 15x and 5 share a common factor? And yes, they do. They share a common factor of 5. So I can write this as 5, the greatest common factor, times the quotient. What do I get when I take 15x and I divide it by 5? Divide 5 out, I get 3x. And what do I get when I take 5 and divide 5 out? I get 1. Be careful here. Sometimes kids will say 0, but that's not true. 5 divided by 5 is 1. Right? 1 times 5 is 5. So when you pull out the common factor of 5, you have a 1 left there. It's very important, and sometimes it's a common mistake of students. Okay, let's look at another example. A little bit more complicated looking. So here we have 3a squared x plus 9ay. In addition to having a numerical common factor, there can be a variable common factor, which is what we start to see here. First of all, I want you to think about what a squared means and write it out in its long factored form. So a squared, you know, means a times a. This would look like 3a x plus 9ay. Often that helps kids see all of the common factors that they can pull out here. First, look at your coefficients. The 3 and the 9 have a common factor of 3. So we pull out that 3. They also, though, both terms have a common factor of a, right? So that's part of the greatest common factor, the a. We pull that out as well. What's left when we divide a 3a out of 3aax? Well, if you're not sure, go off to the side and think about that. When we take 3aax and divide it by 3a, we just have ax left. So we have ax left in our first term, and in the second term, we just have 3y left. So right here, this is the factored form of 3a squared x plus 9ay. You can always check if you factored correctly by doing the distributive property and seeing if you get the original answer back. 3a times ax is 3a squared x. Yep. And 3a times 3y is 9ay. Yep. So you can see you know you factored it correctly. All right, we have another example here. 8c minus 12d plus 9e. Do you see a greatest common factor in all three terms? Actually, there's not one, is there? Yeah, that's possible. Not every algebraic expression is going to have a common factor in all of the terms, in which case you can just say not factorable. Okay? We could, in fact, factor an expression with 3 terms or 4 terms or more, as long as there are a common factor in each of the terms. And here you can see in example 3, it's just not the case. If this would have been a 10e on the end, then we could have factored out a 2. Then that would work. But this one's not factorable. All right, let's move on. Oh, this is just practice. All right, so let's start
12x plus 32. Okay, so look at it, ask yourself, is there a common factor in both terms? Sure. What is it? There's a 2, but you could go higher actually for the 2. Both 12 and 32 share a common factor of 4. So if I factor that out, I'm left with 3x plus 8. That's what it looks like in factor. What about that one? 3kp minus 5ck. Now, in a problem, look not just to see if the coefficients have a common factor, but also the variables. In this example, the coefficients don't have a common factor other than 1, but there is clearly a common factor of k. So factor out the k, and you have left 3p minus 5c. That's the factored form. All right, what do we got over here? 6y squared minus 21yz plus 3y. Ask yourself, is there a common factor in every term? Well, first of all, there's a y squared here, so maybe some of you need to write that out as y times y, minus 21yz plus 3y. You should recognize that the coefficients have a common factor of 3, but the variables also, they share a common factor of y through the whole problem. So I can factor out the 3y, and I'm left with 2y minus 7z plus 3y divided by 3y is 1. There you go. All right, that should be enough to get you going on your homework.